Good morning. Today we are continuing working with probability. We are doing PO40. I can calculate the probability of a single event. So probability is the likelihood of an event occurring. We have our scale of probability. I believe we talked about this last week. Yep. So we talked about that definition and our scale of probability. It's not important. We're going to write it again so we truly remember this. So that scale of probability, remember we had our 0% at one end, 100% at this end, 50% in the middle, 25% is half of that, 75% is in the middle of that. Where would something be likely to happen? Amala? Yeah, above 50% to 100% is likely. If it's at 100%, it is happening. We are outside for recess. That is happening. That's 100% likely going to happen. Right? If it is 75%, this morning, before it was announced we were going out for recess for sure, I was about 80% sure we would make it out. But you never know with the temperature, with the weather. I can't say 100% because it hasn't been announced yet. Because I knew it was questionable. Now it's 100%. It's been announced we are outside. So if it's under 50%, it is unlikely. Under 50% is unlikely. 0%, it is not happening. 0% not happening for sure. 100% definitely happening. Under 50%, unlikely. Above 50%, likely. The closer you get to the 100%, the more likely it is to happen. Closer you get to 0, the more unlikely it is to happen. Then it's a 50-50 chance. It can go either way, same probability. So if it's at 50%, it's the same probability. It can go either way. We have no idea. We can't say it's more likely or unlikely to happen. All right, so there is a probability formula. This you're going to have to know. Right? We're going to use this formula when we talk about probability. There are two different ways we could write it. We could say what you want to happen. Whoops, I need to spell it correctly. Over what could happen. So that's one way of wording it. What you want to have happen over what could happen. When we have that fraction bar, what mathematical operation is that? Christina? Divide. So we know we will take what we want to happen and divide it by what could happen. Another way to word it would be to say desired outcomes over possible outcomes. So desired outcomes over the possible number of outcomes. We're going to see how we use that in just a moment. So make sure that you have the formulas written out. We will be using these a lot. Okay, desired outcomes over possible outcomes. So let me scroll up to show how we use this. All right, so it says calculate the probability of each event, written as both a fraction and a percentage. So if we have our fraction, how do we turn that into a percent? Who remembers? How do we turn a fraction into a percent, Graham? Careful, there is a division in there, but we don't say the smaller one by the larger one. What do we say? The numerator by the denominator could be improper. That numerator could be bigger. You got 103 right out of 100 because you got extra credit points. That numerator could be bigger, right? So you divide the numerator by the denominator. That gives us a decimal. Then we need to turn that decimal into our percent. So you take that 10th and 100th place of the decimal, and that becomes your percent. And if you have anything in the whole place, it's going to be over 100%. So we are going to show our fraction and our percent, and then we're going to write if it's likely or not likely. And we must show our work when we correct this. If I see people not showing their work like I saw on today's assignment, you will not get credit for it. When it says show your work, you must show your work, or there's no credit given, because you're not following directions. So let's look at this first one. You have a bag of 60 marbles. 9 are red, 24 are blue, 15 are white, and 12 are yellow. What is the probability of choosing a red marble? So we want our desired number on top and the possible number on the bottom. So the number of the desired amounts on top, the possible would be on the bottom. So what would my fraction look like? What is my desired number? David?
9 over 60.
Why 9?
9 because that's how many red marbles.
Yeah. I want to choose a red marble, and there are 9 red marbles. So I have 9 possible chances of picking that red marble, right? And then why 60, David?
Because that's how many total marbles are in the bag.
That's how many total marbles there are. The possible number of marble picks is 60. So that's my fraction. 9 over 60. What is 9 divided by 60? Hadley?
4.5.
So I'm going to write that decimal place. Okay, 0.15. If it becomes a decimal that's longer, you have to round to the 100th place. You don't just drop off the thousandths and on. You have to round to that 100th place. Decide, does that 100th place stay the same, or does it round out 1? What percent would 0.15 be?
15%.
Then I'm going to write 15% because I need to write it as a fraction and as a percent. I'm having us put that decimal on there because a lot of times we forget how to round. And somebody might go, but I got 16%. Then we could look at it and say, well, what was your decimal? Did you round correctly? Now, what's the last step I have to do? Harper. Is this likely to happen or not likely? If it's 15%, what should I put, Harper?
Not likely.
Not likely, because that's close to the 0%. So it is not likely I'm going to pick a red marble when I reach my hand into that bag. Let's look at our next one. What is the probability of choosing a yellow marble? What would my fraction be? David?
12 over 60.
12 over 60, because there are 12 yellows. We still have 60 marbles in a bag. What is my decimal? Claire?
0.2.
0.2. What percentage is that? Harper? 20%. 20% is below 50, so again, it is not likely. What is the probability of choosing a blue or white marble? What am I going to put for my fraction? Eleanor?
50%. 39 over 60.
I need to add up how many blue and how many white, which would be 39 over by 60. What decimal do I get? Luke, which turns into 65%. 65%, is that likely or not likely? Christina? Likely. It is above 50%, so it is likely to happen. And our last one. What is the probability of choosing a red, white, or yellow marble? Let me scroll up. What fraction is that going to be? Graham,
36 over 60.
if I add red, white, and yellow together, I get 36. I still have 60 marbles in our bag. What is 36 divided by 60? Adley,
Wait,
0.6. What percent is 0.6? Skylar?
60%.
60%. 60% is above 50, so it is likely to happen. Now, our second page, we have to think about what we are being asked. This first page is a little bit easier, just working with our marbles. We're going to do the same thing, writing a fraction, turning it into a percentage, showing our work. Now, on the second page, it doesn't say that you have to put likely or unlikely, but you can. Don't get me wrong. You can think to yourself, is this likely or unlikely? You do have to write your fraction, put it as a decimal, and then tell me the percentage. That is showing your work. So the letters of the alphabet, 26, are placed in a hat. What is the probability of choosing a vowel? How many vowels are there in the alphabet? Claire?
5.
5. So there are 5 desired outcomes. How many consonants are there? If there are 5 vowels, how many consonants are there? Amala? 21. What is the probability of choosing a letter A to N or S to Z? You need to figure out what that number is. Eleanor?
Are we having Y?
What do you think? Do you think that just answered that question? Yeah. That answered the question though. A-E-I-O-U. We went through this as a class, so we know what number to put. Okay, so if I put 5, that kind of answered that. We're not doing the sometimes Y as a vowel. All right, because I didn't say 6. So we're all using the 5 for the 5 always vowels. What is the probability of choosing any letter in the phrase SVDP Royals? So you need to figure out what the desired number is and what the possible number is. Flipping our coin. You flip a coin 5 times. What is the probability of getting all 5 heads? So you need to think to yourself, how many chances would that be? What do you think our numerator number would be? What is our desired outcome to get all 5 heads? How many chances? If I flip 5 times and they all land on heads, what would that number be? How many times could I flip it and get all 5 heads? If I flip a coin 5 times and each time it lands on heads, how many?
20%?
No. So we need to think to ourselves, I've got 5 outcomes, or 5 events. Flip 1, flip 2, flip 3, flip 4, flip 5. There's 5 events. I want heads each time. how many times could I get 5 heads? What are the odds? What's the probability, not odds, what's the probability of getting, how many desired outcomes are there? Did I say heads, tails, heads, tails, heads? Or heads, tails, heads, tails, tails? 3 heads and 2 tails? No, it's all 5 heads. David?
The total number of outcomes that it could possibly be short.
No.
No.
My first question was the numerator. Desired outcomes. Harper? Nope. No. 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 If I am flipping my coins, my desired outcome is heads, 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 heads. It is very specific. There is only one outcome I'm looking for. Heads, 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 heads. I'm not saying 3 heads and 2 tails in any order. Then we would have multiple. We could have the 3 heads and then 2 tails. We could have the heads, tails, heads, tails, heads. There is a variety of ways we could get it. Doing all 5 heads, there's only one way to get all 5 heads. How many possible outcomes are there? How many possible outcomes are there? How do we figure that out? Thinking about what we did in our last objective, how do we figure out how many possible outcomes are there? Each of these events has 2 possible outcomes, right? It's a coin toss each time, so there's 2 possible outcomes. How many total possible outcomes is that, Robbie?
32.
32. Because 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. 2 times 2 times 2 times 2. When we do that 5 times, we get 32 possible outcomes. You see how we did that? You're going to need to understand that for the rest of these ones. Does that make sense? So that bottom number, possible number of outcomes, use that counting principle. Think about how many events there are, how many possible outcomes for each event to get that total possible outcomes on the bottom. So you're really going to want to write it out so you remember how you got 1 over 32. Don't just put 1 over 32. Write out what I did to help you remember how you got that. Because that's kind of key. If we don't know how we got to the 32, it doesn't help us. Any questions? Okay. If you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.